Water molecules are made up of polar covalent bonds between an oxygen and two hydrogen atoms. Water molecules attract to each other by hydrogen bonding, which is the attraction of hydrogens to oxygen. Because oxygen is more electronegative because of its 8 electrons, it has a partial negative charge. And hydrogen, which has a partial positive charge, is attracted to the oxygen atom. Therefore, water molecules are attracted to each other.
Cohesion is the ability of water molecules to cling to each other due to hydrogen bonding. Surface tension is the ability of the molecules close to the surface to cling to each other than the air above due to hydrogen bonding. Capillary action is the tendency of a liquid in a material to rise or fall as a result of surface tension. The pin floats because the mass of the pin is less than the mass of the water as a whole. If the mass of the pin was more than the mass of the water, the pin would sink. When the detergent was put in, the hydrogen bonds were disrupted, causing the pin to sink.
Capillary action uses both adhesion and cohesion. Adhesion to stick and climb to the sides of the non-water surface of the tubule, and cohesion to pull those other water molecules along with it. Water molecules are stuck together through a hydrogen bond. This attraction allows water to have its unique properties. In this case, the hydrogen bond causes adhesion, the ability for water molecules to stick to other substances, or anything that has a charge. It is most commonly seen in plants. Capillary action is how water climbs from root to leaves. Water is pulled in through the roots in the microscopic tubes called xylem that travel up the plant into its leaves, where the sun's energy evaporates the water released from the leaves' pores. This evaporation pulls more water with it through cohesion, causing the cycle of pulling water up through the leaves and evaporating it to continue.
Evaporative cooling is the use of energy, in this case heat, to break hydrogen bonds between water molecules. As you will see in this demonstration later on with the video, 2 thermometers were used, and both were wrapped in cheesecloth. One of the cheesecloth was wet. As time passes by, the thermometer with the wet cheesecloth was more decreased in temperature than the one that wasn't wet. This happens due to evaporative cooling. The water molecules uses the heat from the bulb of the thermometer to break the hydrogen bonds. As the hydrogen bonds were broken, water molecules were released into the air as evaporation or vapor. And with it, heat was also released. Therefore, the thermometer has a more decreased temperature than the one that wasn't wet.